Greetings everyone. Today we're going to explore how to solve systems using matrix equations and their inverses. So we've been solving using algebraic methods, elimination, substitution, and as you know, 2 by 2, not too bad. 3 by 3 gets to be a little more work, but not too bad. How about if we use matrices in our calculators and make that process a lot more efficient? So first of all, you'll definitely need your notes. And second of all, please remember to make a little left column so we can go back if we need to make some extra notes. All right, so our goal today is we want to be able to solve an equation or a system of linear equations using matrix inverses. All right, so a couple of notes to get us started so we can get this concept understood. A linear system can be written as a matrix equation with A times X equals B. So for example, if I take a look here, I have my coefficients in a matrix. I have my variables in the second matrix. And I have my solutions, or what those equations are equal to, in a matrix. So I'm really just organizing that information. So again, this is what it would look like if I have my 5x and my negative 4y, my 1x and my 2y. So we can see if we were to multiply these two matrices, this is what we would end up with for equations. So the setup's pretty straightforward, pretty basic. All right, so let's start off just a simple example. Let's just write this, write these equations as a matrix. We're not even going to solve yet. So if I want to write this as a matrix, I know I've got the variables of x and y. I know I have the constants or solutions as 5 and 10. And I have the values of -1, +4, 2, and -1. Watch out for your signs, wherever it's positive, negative. Watch out for putting a value of 1 to represent that coefficient. If there is no variable, in that case, we would replace with a 0. All right, let's go over the steps for solving. So this is a little more involved, okay? So suppose I had ax equals b. How would I solve for x? So in basic algebra processes, we'd probably just say, hey, let's divide by a, okay? But the problem is we haven't been working with and won't work with dividing matrices. So this dividing option all of a sudden isn't an option. So instead, we've talked about multiplying both sides by the inverse. So in this case, I could multiply both sides by 1 over a. That would be the same. That would eliminate and isolate the x variable. So with matrices, we can do the same thing. We can solve by multiplying both sides. Oops, I should use parentheses there. Multiplying both sides by the inverse of the matrix. Okay, so we've been working with inverses, so we can take care of that. So here's just some, I had this prepared even though I was writing there. The one thing we do have to specifically talk about is typically we write it like this, right? We multiply both sides. But here's the problem. Remember that multiplication isn't commutative when we're talking about matrices, okay? So we've got a problem. We can't multiply b times the inverse of a necessarily. So order matters. So right here, we actually have to take the inverse and multiply it by the constant matrix. So order matters, okay? So here's the thing. If you go to multiply and it doesn't work, you got to flip it around. We got to make it work for multiplication. All right, so let's take a look at how to solve systems of equations using matrices. So let's go through a full example. So my first step, I'm going to number my steps. So if you want to add details to those numbers, you can do that. So I'm going to say step 1 is going to be to write your matrices. So we need to do our coefficient matrix. we need our variable matrix, and we need our solution or our constants matrix. Okay. Our second step is going to be to find our inverse. So remember those steps from the previous lesson. So to find the inverse, I'm going to start by taking 1 over my determinant of my coefficients matrix. So the determinant of my coefficients matrix is -3 times -1, subtract 2 times 4. If I take a look, that's going to be 1 over 3 minus 8, which is going to be -1/5. Doesn't matter where the negative is, numerator, denominator, or out front. Okay, so I want to take this value and I want to multiply it by, now remember these steps, I need to flip my A and D, and I need to change the signs of my B and my C. Okay, so now this became my scalar, and I need to multiply it. So yes, we're going to have fractions. It's going to happen. You can do it. -1/5 times -1, hey, that's just 1/5. See, already easy. A negative times a negative is a positive. 4 times a fifth is 4/5. Negative times a negative positive. 2 times a fifth is 2/5. Negative times a negative is a positive, and we get 3/5. So see, we got fractions, but it was easy to multiply at least. All right, so this is our inverse matrix. Okay, we got to do a little bit of work to get there. So my third step, okay, I need to multiply both sides of step 1 by my inverse matrix. So I've got 1/5, 2/5, 3/5, 4/5. Kind of clever how that worked out, right? And I'm going to multiply it by -3 to -1/4. I've still got my variable matrix. Okay, order matters. I have to have my inverse first and then multiply by the constants. Okay, if I don't do that, I can't multiply them. So now here's what happens. Here's the easy work. I wrote it all out, but this right here, anytime you multiply a matrix by its inverse, it's 1. That's why we do that. That's how we got rid of or moved that matrix to the other side. Okay, so I'm only left with x over y. Oops, I shouldn't have put over. Sorry. Let's get rid of that. So my matrix, my variable matrix of x, y. Now here's where I got to do a little bit of work. I have to multiply this 2 by 2 by this 2 by 1, which means my answer is going to be a 2 by 1. Okay, I'm going to show a little bit of work. So first of all, I need 1/5 times 5. Oh, well that's just 1. And I need 4/5 times -10, which would be -45, which would end up being -8. Okay. Then I need to take 2/5 times 5. Well, that's handy. That's just 2. And I need 3/5 times -10, which is -30 over 5, which is actually just a -6. So my solution, I keep putting that bar. Why do I do that? I'm sorry, that should be x, y. If I simplify this, I end up with a -7 and a -4. So see how that worked out nice and tidy. And we're used to writing our solutions as a point, so we can still do that. Okay, but these are our solutions. Okay, just as before, we could plug them in and check. Now, some of you might be thinking, Mrs. Morfett, again, solving using elimination or substitution is way easier than using these matrices. But here's the thing. When we get to 3 by 3s, it's going to make more sense on why we want to use matrices, because we're going to use our calculators. All right, so let's take a look at another example. Yes, it's another XY, so I do want to show all the steps because I want you to make sure you understand the process. There are multiple ways to use matrices. This specifically is using inverses. So if you Google or YouTube other resources, make sure you find solving systems using inverse matrices. You got to be specific. All right, so my first step is to identify my matrices. Coefficient matrix, variable matrix, and I'm going to leave a space here, our solution matrix. Okay, and I'm going to leave some space there because I actually want to write to the left of that for my next step. Okay, all right, step 2 is to find my inverse. All right, so to find my inverse, here's what we need to do. I need to start off with 1 over the determinant of my coefficient matrix. So 1 over 7 times -4 minus 14 times 3. So those are my diagonals, right? 1 over, let's take a look. We get -28 and a -42, which gets me to 1 over -70. Oh, that's a fun number. All right, -1/70th, but we need to scalar multiply that by, okay, remember this matrix here, we flip our A and our D, and we change the signs of our B and our C, okay? So now I need to multiply that scalar. All right, who's ready for some fractions? Okay, negative times negative is positive. 4/70ths can cut in half to 2/35ths. Negative times negative is positive. 3 over 70 doesn't reduce, so we'll leave that. Negative times negative is positive. 14 over 70, that does reduce quite a bit, actually. That reduces down to 1/5. Okay? And a negative times a positive is a negative. 7 over 70 goes down to 1/10. Okay? So not too crazy, leave them as improper. All right, step 3 is I'm going to multiply my original by my new inverse matrices. So that's why I left a little bit of room here, because I'm just going to add it to my original matrices. Not add it, sorry, multiply it. You gotta watch what I'm saying. All right, so on this left side there, anytime you multiply a matrix by its inverse, you get 1. That's the whole reason we do it, is so that this goes away. All right, so I'm left with my variable matrix, and now I need to multiply. Who's ready for some fun? Okay, we have 11 times 2/35ths. I'm going to do a little bit of work here. Let me set this up a bit. Okay, that's going to get me to 22/35ths, and I need to, add 3/70ths times 2, which would be 6/70ths. All right. All right, next I need to take 1/5 times 11, which would be 11/5ths. And I'm going to add on -1/10 times 2. So that would be a -2/10, which reduces down to 1/5. Okay, so just write those steps out so you can see those crazy fractions, but they're going to be easier to use than you think. Okay, so if I add, I need a like denominator. Let's change this to 70 and 44. That's not too bad. So we end up with 50/70ths if I add these. So that reduces even more. That's 5/7. Okay, so not too bad. The common denominators should sort of work themselves out. All right, then I have 11/5 minus 1/5. Hey, we already have a common denominator. It gets me to 10/5, which is 2. So my final solution is 5/7 and 2. Okay, I can always still check my work by plugging it into my original functions and making sure they are true. Okay, the real reason why we want to solve using matrices, right here. Make sure you have your calculator prepared. I am not going to make you do inverses of a 3x3 by hand. So here's where that calculator has a great purpose and why we even have this process. Okay, so first step, I am still going to write out my matrices. Okay, so step 1, let's start off with my coefficient matrix. Then I have my variable matrix. Okay, so when you're using a calculator on a test, I still need to see some work. This would be your work. Okay, I want to see this set up. I want to make sure you understand what you're typing into your calculator. Okay, so step 2 was to find your inverse. Here's where you're going to use your calculator, you guys. You're literally going to keep this matrix, and in your calculator, you're going to say 2 to the negative 1 equals. So super easy. I already typed it in my calculator. Here's what I got. So please make sure you get the same thing. Do that work. Make sure you understand how to type it in and that we get the same thing. So that's my inverse. Step 3, I'm going to multiply by the inverse, just as I did before. Okay, we do that because then that cancels. Oops, and I forgot that I need to leave a little bit of space here because we need to multiply our inverse matrix by our constant matrix. I have to leave, oops, I have to leave a space there. I'm going to cut off my feet there. Because the order matters. Matrix multiplication is not commutative. It matters the order in which you multiply. So I'm going to throw that in front so I can actually multiply. Okay, so now I can take care of that multiplication. Now, here's what's pretty handy, you guys. You could multiply this out, but guess what? You can still use your calculator, okay? I'm going to go through the multiplication by hand, but if you know how to, let me just throw this out there, you can store this answer matrix, okay? See if you can figure out how to do that, and then you can just multiply it by that constant matrix. So you can have the calculator do that for you too, but it takes a little bit of work to figure that out. Okay, so I'm going to take care of this multiplication. I know I'm going to end up with a 3 by 1. So I'm going to show my work a little bit first. Okay, so I'm going to show those multiplication steps. Give myself a little bit more room. All right, so first, -1 times -1 is 1. 1 times 1 is 1. 0 times -2 is 0. I'm going to add these together. Okay, then I've got middle left. -1 times -1 is 1. 0 times 1 is 0. 1 times -2 is -2. Then the bottom left. 6 times -1, -6. -2 times 1, -2. -3 times -2, +6. Okay, so now if I actually add those values, I end up with 2, -1, -2. Boom, there's my answers. Okay, how quick was that? I know my solution is 2, -1, -2. I don't know about you, but using my calculator, that was way quicker than actually doing triple elimination. All right, so here's the reason why we have this process. So we can solve equations with 3 or more variables. A challenge for you. We're not accepting the extra credit anymore because now we know how to use calculators for it. But that was a 4 by 4. Okay, think about how that would work. We could also do that here using our calculators. Okay, one last one. Practice using your calculator. I'm going to write out the steps. Again, these steps I'm writing out are what I would expect on a test. Don't just plug it all in and spit out an answer. Because if you do something wrong, guess what? I can't give you any partial credit. So show me your steps. Show me you understand the process. So first step, I need to write my coefficient matrix. So I've got a -1, a 3, a 5, a 2, a 1. Oh, I'm missing, so I gotta put a 0, a -9, -8, -4. I have my variable matrix, x, y, z, and equals, I'm gonna leave some space. I have my constant matrix, -15, 1, and 12. All right, step 2 is to find my inverse. So in my calculator, I would take my coefficient matrix and I would say to the -1 to get my answer or my inverse, excuse me, of, let's see, I plugged it in already and I got 4/7, 4, 5/7, -8/7, -7, -10/7, 1, 5, 1. Look how pretty that is with all those fractions. Aren't you glad you have your calculator? All right, don't forget about that fraction key. If you're seeing all these decimals, click the math button, press enter, enter. It's going to select fraction and turn your answer to a fraction. All right, step 3. I need to multiply. Guess what? I'm going to save myself some time. I'm multiplying by the inverse of A. That's going to go away. Okay. Here, though, order matters when I multiply. I have 4/7, 4, 5/7, -8/7, -7, -10/7, 1, 5, 1. All right, who wants to multiply this by hand? If you do, go check out Miss Marsh's video. I was watching it. She does all that multiplication by hand. Go her. But I'm going to use my calculator. So you've already got this matrix in there. If you have figured out yet how to store it, okay, create this matrix, store it, and then multiply those two matrices. All right. Now, when you multiply those, let me take a look here. I already did that in my calculator. We end up with a matrix of 4, -7, and 2. All those crazy fractions to get our nice, clean answer of 4, -7, 2. All right? So again, I want to see this written out on a test. I want to see you understand the process, not just punch and write down the answer, okay? Let me know if you have any questions. My suggestion is if you're struggling with this, rewatch the video, you guys. It's hard to watch, get all the information, and write at the same time. So you're done writing, rewatch a couple of examples. Preparing for next class, okay? So just take a look in Google Classroom to discuss when's our next learning check. Moving forward, what kind of homework's posted in Google Classroom. Make sure you stay up on that. Make sure these notes are good to go. Remind your friends to take these notes. You need to listen to this with sound. So if you're trying, if you try to do this without that, it's going to be a little bit tough. All right. And then just keep in touch, you guys. If you have questions, shoot me an email. Go to the Sabre Center, ask some questions. Okay. Especially with the calculator. Here we're really creating a need for a calculator at home. So if you don't have one personally, you got some options online, but I would strongly start thinking about getting one to make your life a little easier. Okay, you can find them cheaper on BizMan Online, you can find them cheaper on Facebook Marketplace. You can save some money that way, or ask friends and family, see who has one. All right, until next time, have a good one.